All right, and this is the last lecture video for Chapter 9. Again, we do not get into naming the muscles in lecture. That is the lab portion. And so in this, we're just going to look at some basic ideas of actions and how muscles work and how they work together. So skeletal muscles generate many different types of body movements. The action of the muscle depends mainly on the factors that are going to either be the type of joint it's associated with or the way the muscle is attached to the joint on either side. Now, the way they work is they are, in physics, they would be considered this type of balancing act with bones as levers. So we have a rigid bar or rod, which is the bone. We have a pivot point or fulcrum, which is the joint. We have something that needs to be moved, which provides resistance, and the force that supplies the energy for the movement is the muscles. Right? So when we are doing this, we're going to look at the elbow. The next slide is going to be a picture of someone flexing the elbow or pulling something up, and so we'll see how this kind of works in here. It represents a third-class lever. Sorry, so the next one will have the arm, but these are talking about first-class levers when I've got a force pushing down, and it's like a seesaw. All right, I've got a resistance. Second-class lever is like a wheelbarrow, where I've got a fulcrum, and then the force is pushing up against this resistance. The resistance is between the force and the fulcrum, and then the third-class lever is going to be this, where we're going to look at this is what our arm is. I am not really worried about you knowing that it's a third-class lever. For me in my class, that's our. I hope you understand this, but this is more physics, and this isn't a physics class. So when we look at this, I just want you to have the understanding of what's happening. So I've got a weight, which is a resistance, and I am trying to raise it. So I've got the weight over here, this is the fulcrum, and so the force is my bicep brachii. As the bicep brachii pulls, now again, remember that in muscles we have an origin, the fixated part, and we'll look at this again in a minute, and an insertion, which is the movable part. So I'm moving the insertion point here and moving it closer to the origin, and in doing that, I am moving the bones in the direction that's going to help move the resistance up. In this, if I am pulling down, so I'm extending my elbow, I still have the fulcrum here, and so my force is going down. I've got a pulley which allows my downward force to have an upward force on the resistance, and the force in this is going to be contributed by the tricep. Right? So we've got force pulling through a fulcrum to move resistance. Now, this is what I was saying before. When a muscle contracts, it doesn't contract evenly. I'm going to have one end that does not move. That is called the origin. And then I have another end that is pulled towards the origin, and it is called the insertion. So going back to flexing of my elbow, if I draw my little thing here, and I've got, this is my bicep brachii here. It doesn't look like it, I know. But again, it's attached here to my radius. When I go to contract my muscle to bring and flex my forearm up, I am going to cause a shortening of this muscle, but it doesn't move evenly. The origin is up here at the shoulder. The insertion is down here at the radius, so that when it contracts, it pulls the radius up to my shoulder. When I go to take a sip of coffee, I don't pull my head down to the table. I pull the cup up to my head. One part doesn't move, that's the origin. The other part moves, that's the insertion. On this, it shows it again. When we were looking at the radius in lab, we had the radial tuberosity. The radial tuberosity is where the tendon of the bicep brachii inserts, because there's a lot of pressure on that. So we put a lot of bone down there. Now again, not going to get into this. This is the intertubercle groove we looked at in lab. That's one of the long head of the bicep brachii. We have another one that attaches to the coracoid process. This is not what we're looking at. This is not part of this. But I do want you to know this is the insertion. The origin is up here in the shoulder. This does not move. This moves. Now, when muscles move, it's not just as simple as one or two muscles moving. There's a complicated dance, and there are certain things that are going to be common. And if you've ever taken theater, these names are going to sound familiar. So I have something that's going to have kind of the same name here. This is the same thing. An agonist or a prime mover. This is the muscle that causes the action. This is the primary muscle of movement for whatever action we're talking about. So this would be, if we're talking about movies, this is the star of the movie. This is the headliner of the movie. But then we're going to have B-list stars. The co-stars, the one that are helping, but they're not doing all the heavy lifting. All right, so we'll have synergists. These synergists are muscles that help, they aid in it, but they're not the prime mover. And then we're going to have the bad guy, or the one that is going against everything else. This is called the antagonist. So if I'm talking about flexion of my elbow, the prime mover is the bicep brachii, or the bicep brachii. We will have a couple other muscles that will help, that will be synergists, but the bicep brachii is the agonist or prime mover. Now, in flexion, the muscle that's going to provide the resistance, that's going to be opposite, the antagonist, would be the tricep brachii. Now, this, I messed up. I'm not going back, but this I just want to show you. These are all the muscles, all right, that we're going through. There's another slide that has the ones on the posterior. This is not this lab or this lecture. That's more lab stuff. But I expect you to know certain things. I would expect you to know, if I ask a question about what we commonly call the six-pack, you should definitely know that is the rectus abdominis. You should know things about the quadricep and the hamstring. You should know about the rotator cuff and the muscles of mastication. Groups of muscles are easy targets. Now, I want to go back to one thing, and I'm not going back to the slide, but we had the prime mover. So on the bicep brachii is the prime mover of elbow flexion. The brachialis is going to be a synergist. It helps. And then the tricep brachii is the antagonist. But one other thing I want you to know, and it's really important in many areas, but more so in the shoulder, is there is a group of muscles called fixators. Now, fixators, all their job is, and I'm going to misspell it out because I'm trying to worry about getting this. Their job is to stabilize the origin. So, for instance, the bicep brachii has the two heads, and most of it's going to be dealing with the scapula. Now, you have a group of muscles around the scapula that are holding it under the spine in different areas and whatever. Those are fixators. They stabilize and they allow for the origin, again, to be stable and gives us more power. This is one of the real problems if you have a separated shoulder or damage some muscles in the middle part of your back, in the fact that now those fixators aren't able to stabilize the shoulder. And so it's going to cause the origin to be unstable, and it decreases the strength of contraction greatly. So it's a fixator. All right. Now, with that said, this is the end of it. Again, this is looking at the back. These are muscles that, again, I'm not going to have pictures on our lecture test. This will be lab, but I still expect you to know many of the things about it. But the test won't be naming muscles. That is, again, lab. So that is it for Chapter 9. I hope that all of this made sense, and if not, I hope when you're watching it, if you go back and look at it, you'll see what we're talking about. But I hope everybody is doing well. Enjoy your day, and we will talk soon.